get ready to solve some number problems. We're going to start with a couple of one number problems, and then we'll move on to two number problems. We're on this page in your notes, and if you take a look at example 1, it says the sum of a number and 10 is 26. Find the number. So with all types of word problems, it's very important to set up let statements. Right now the let statements seem a little redundant, but as we progress to more complex problem solving, the let statements are really going to be very, very important. So it's important to establish that habit with easy problems. I set up my let statement with whatever I'm trying to find. I'm trying to find the number. So I let x equal the number. And you can abbreviate, that's fine. Good with abbreviations. And then I just set up the equation and solve it. So the sum meaning to add a number, and 10 is 26. And then we would obviously solve that and we get x equals 16. Now the beauty of let statements is that word problems require word answers. So you can just go back to your let statement and you can go the number equals 16 and then you're all set. Works out nicely, right? So I'm going to go down and do number 3 because that one has a fraction, and 2/5 of a number decreased by 10 is equal to 8. Find the number. So I'm going to let n equal the number this time just to be different. 2/5 of a number decreased by 10 is equal to 8. And then I just solve that. It's a two-step equation. So 2/5 n equals 18. I multiply both sides by 5/2, multiplicative reciprocal or multiplicative inverse. I get 45. So I can go back and use my let statement or my answer box. Easy? Easy. Why don't you go ahead and do 2, 4, 5, and 6. 6 is a little different, but go ahead and test yourself. Okie dokie, I have the answers up there for you, so go ahead and check your work. Make sure you have let statements, make sure you have a circled or boxed final answer, make sure you are showing your work. And for number 6, I didn't completely answer it. I'd like to know what you got. Now there is a strategy that we will use to solving these, but right here, if I have a number squared equals 196, what is an inverse operation of squaring? The inverse operation of squaring is taking the square root. So essentially what I need to do here is take the square root of both sides, and I would get x equals 14. But there's a little detail that we're forgetting about, and that little detail is when I square a number, really there are two answers. So this has to be positive or negative square root of 196 because negative 14 also is an answer to that equation. The numbers are in this case. Let's take a look at two number problems. The smaller of two numbers is 6 less than the larger. If 2 times the larger is equal to 8 times the smaller, find the two numbers. Well, again, here I have to find the two numbers. So I can set it up with the smaller number as x or the larger number as x. Usually we pick the number or the item that we know the least about. Well, I know the smaller is 6 less than the larger, so I let x equal the larger number. And then the smaller is 6 less than, so remember it's less than, it has to come after, is going to be the smaller number. And if 2 times the larger, so that's 2x, that's equal to 8 times the smaller. Now this whole thing is my smaller number. So I have to use the x minus 6, and you're going to want to use parentheses. Then I can go back and fill in my let statement. So the larger number is 8 and the smaller number is 2. Now to check this, I'm going to want to check it with those numbers. If 2 times the larger, well, 2 times the larger is 16. Is that equal to 8 times the smaller? Yes, 8 times 2 is 16. Easy to check. And you should be at least mentally checking these. Let's go on to the next problem below. The length of a rectangle is 3 times its width. Now the nice thing about rectangle problems is that you don't need to do a let statement. You can do a picture. The length of a rectangle is 3 times the width, so call the width W. I don't know anything about the width. I know the length is 3 times as much. The perimeter is 72 meters, so the perimeter is 72 meters. Now the biggest problem with perimeter problems is students tend to say 4W equals 72. Well, that's only halfway around it, so you can do one of two things. You can either multiply 2 by length plus width, or you can add 2L plus 2W to get the perimeter. I'm going to go ahead and do 2 times 4W equals 72, 8W equals 72, and W equals 9. So my width is 9. I'm going to write this over here. The width is 9. Don't forget about your units. So I have meters, which means the length is 27. And 9 plus 27, well, 9 plus 27 is 36, and 36 times 2 is in fact 72. So it checks. So why don't you go ahead and try the other two problems and then come back and check. Occasionally I have students that don't know how to represent that number 9. One number is twice another number if the larger is diminished by. It doesn't really matter. We know that one number is twice another. So you could have written larger here and smaller here. I just did one number and another number. It really doesn't matter as long as you know what you're representing. In number 4, yep, you can get fractional answers. If I add 35 halves and 5 halves, I get 40 halves, and 40 halves is 20 feet, and twice that would check for my answer. Now you have a number of different problems in your practice packet, so you could go ahead and solve 1 through 5 and bring those in tomorrow, and we'll check them and continue with more number problems. Have a great night, everybody.